So a few weeks back I did a video looking at this machine behind us here. It is a Compton Mackin organ. We got this one from the Lucien Nunes Vaz collection. It's one of quite a few of the machines that we've been talking about recently from Lucien's collection. Lucien very much liked Compton organs, and this one is a slightly late Compton Mackin type. It's a skeleton box, like later on they were built into these basically shelving rack. In the last video we looked at how this worked. It's basically a collection of tone wheels, electrostatic tone wheels, that were actually developed to circumnavigate a patent that Hammond had on the Hammond tone wheel. That is a tone wheel that relied on electromagnetism, so as it span around, it made an oscillation sound, which is a similar principle to a vibrating guitar string and a pickup and a dynamic mic, for instance. Well, the tone wheels in the Compton organ are electrostatic. They rely on variable capacitance. On the inside, these are absolutely beautiful. We had a look at them in the last video and we got them going with a DeWalt drill, managed to play it. And this, if we're looking at mic comparisons, is much like a condenser microphone, which also relies on the principles of electrostaticness. Anyway, Compton boxes came in all shapes and sizes. This one has 4 sets of tone wheels. There's 3 on the front that have different overtones. I think there's different waveforms in them, but they're a bit of a pain to remove to have a look. And then there's also a larger set on the back, which are more like the older 347s and such. It's a little bit of an all bells and whistles kind of Compton organ because there's a lot of ranks and there's a lot of tone wheels. But because there's a lot of it, that means there's a lot of things that could go wrong, and some of it might have gone wrong. Some of them might have very much gone wrong. So in the last video, we were only able to get sound out of it, treating it like a very complicated, massive stylophone. Around this side, there is a test panel. This test panel has a crocodile clip, so when you're in the basement or wherever this is, which is usually out of the way, away from the console, away from the church space or theatre space, because this is actually relatively noisy when it's running. This means that the engineers or whoever's fixing it can test it to try and replicate the problem that was being played on the console. In the last video, we spoke about turning this into a MIDI controlled Compton organ, possibly one of the only ones around. I am not aware of any Compton tone wheel organs that have been midified. Please link below if there has, because if not, this might be the first one. We don't know. I hope it isn't, because it's quite an obvious thing to do to one of these. Anyway, much like Joans organ, which is the pipe organ that we midified, we realised when chopping up the wires that there was so many wires, there was no point in doing it that method and that way, relying on relay boxes for the stops and stuff down the Arduino route, and that means that all of the Winchests are only connected by a single cable, MIDI. MIDI, of course, being the musical USB. It's the multi-purpose musical magical wire of doom. Anyway, I mentioned in that video we can't use the circuit boards that we designed for Joans organ because this actually works the opposite way around. Joans organ, the big common wire that connects to all of the relays underneath the pipes is 12 to 18 volts. And then you send the other side of the relays to ground via the chips that we've made to make it work with MIDI. Well, with this one, it's around the other way. We need to send 24 volts to each of the relays to turn them on and off, which means we need to use a different chip. And since we were using a different chip and a different circuit, which is right here, I figured I may as well redesign it and make the circuit board a little bit more purposeful and also have more inputs, because this one needs a lot more inputs than it looks like it needs. So on the test board, all of those metal pins correlate to either a stop, which is a sound setting on an organ, or a keyboard key. A key on the organ. In total, it's made for 3 sets of keyboards with 62 keys each. There's also a pedal board for your feet to play, and then there's also multiple setting stop buttons. All of this altogether means we need about, quick maths, how many is it? We need about 350 inputs to be able to turn all of these things on and off. So I started by designing this circuit board. This circuit board runs on a micro Arduino Mega, and it's also got these ULN2981A high-sided transistor drivers. What these do is they take the signal from the Arduino, and this basically means that the Arduino can send out 24 volts instead of just 5 volts without things blowing up. In total, on every board, there's 8 of these ULN2981s, and then there's these D sub-connectors at the bottom, which means you can plug all of the connectors in and remove it all. So once the circuit boards turned up, I soldered them all together. Before we can put these circuit boards into use in the organ, we need to do a little bit of housekeeping on the organ equipment itself. In the previous video, we only used the built-in power amplifiers. Those are the things at the top. There's 2 stereo amplifiers in total. This makes it a little bit less flexible in the museum than I would like. So what I did was I made this panel that had jack outputs and soldered these directly to the outputs of the preamplifiers from the tone wheels. Instead of going into the power amplifiers to power speakers that way, this one can also have jack inputs, so we can plug it into anything really. For instance, now that's all wired in, we can plug it into the quad Leslie speaker setup that we built a couple of weeks ago. Now we know it's somewhat working. Well, it's working as well as it did. We can start removing that massive multi-core cable that got chopped off. That used to go to the organ console, the keyboards and things elsewhere in the building. This got lopped off, so we're removing the remnants of that console, because the plan is we're going to swap this cable with those circuit boards that we made. That's going to mean that we can control this all with a single MIDI cable. And yeah, the test panel, it literally is the connection between this machine and the keyboards. So when we take that off, we can add new ones, which are ribbon cables. I'm using ribbon cables and D-sub connectors. We're going to solder them in so we can actually connect up these circuit boards bit by bit. This took a little bit of time because it was quite tedious, because there's just a bunch of wires, but it's the kind of thing you just gotta do when you do these kind of things, you know? So now we've got the wires connected to the test panel. We get one of the circuit boards, plop it in place, bolt it down, and then connect it in. We actually need 5 of these circuit boards in this machine, but let's test it first. I haven't even tested it, so fingers crossed this even works. I had to upload the MIDI code, which is basically the same MIDI code as Joans Organ's MIDI code, which is available on my website, but it's slightly adjusted to make sure all of the notes hit on the right keys on the beat step, which is what I'm testing with there. As you can hear, all of the relay panels are whirring away. There's one of these relay panels per keyboard, and there's also one hiding around the corner for the pedal notes, and each of these are very finicky. In fact, I had to spend quite a while fine-tuning a bunch of them, because some of them didn't work for one reason or another. They're very fragile, and this thing's been bumped around here and there probably for 40 years, so it needed a little bit of fine-tuning and adjustment here and there until it started singing a tune. Now we can play it with a keyboard. I started noticing all of the problems they had. For instance, there was one of the tone wheels that just wasn't in tune. It wasn't working, and I noticed it wasn't running as quickly as the rest of them. Under further inspection, I found that it wasn't spinning freely. So in order to figure out what it was actually doing, I had to surgically remove it, have a look on the inside, and it turns out that some of the oil, when I was trying to free that one, because it's always been a little bit on the stiff side, the oil got in and managed to kind of like add a bit more friction to the back of the electrostatic pickup disc. I'm going to call it that. It sounds fun. Sounds good enough. So after I cleaned off the oil and checked the bearing shaft and things like that, popped it back in, and it started to play in tune again, luckily. There is, however, a problem I still haven't fixed here, and I'm hoping to do it by the next video when we get the rest of this wired in, and that is, there must be, in all of these thousands of wires in this machine, 2 wires that are touching that shouldn't be touching, because there's 2 notes playing at the same time on the furthest end of the tone wheels. That means if you play either of these 2 notes, they're exactly the same. I'll find it by the next video. I must be honest, I haven't tried that hard yet to find it. It'll turn up. Anyway, now it's all wired in. We've got a keyboard set wired in. We could get over to the fancy stylophone over there, stylophone in a few of the organ settings, or stops if you want to call them like that, and just see what this thing is actually supposed to sound like. It's not going to sound like it is all guns blazing, because we haven't wired in all of the keyboards yet, but we can get a good idea of what this thing is supposed to do. Right, it's running. Should be playing something. Let's just put in some of the stops. Oh dear. overwhelming, the sound, I've got to be honest, but we'll get a test program. Well, what can I say? It sounds like an organ. What were you expecting? I don't know, something from the moon. But funnily enough, it does actually, if anything, sound more like a church organ than the actual church organ sitting over there. Anyway, let's stylophone in a few more organ stops. You know, it is what it is. It's an old church organ, but we've modified it with the jack outputs, remember? So that means we can mess with the sounds and plug it through effects pedals and things like that. So let's see what this sounds like when we plug it through something like this effects pedal, the Microcosm. We can explore more things we can plug this into in the next video, which we will be wiring more of those circuit boards into this so we can control everything in here, so we can hear everything and let it do what organs are supposed to do. After we're done with this, then we need to focus on the console, which is not just going to control this, it's going to control everything that is in this room. In fact, one of the next machines we're working on is midifying tubular bells. Ding dong dong. That's going to be cool. Anyway, there's full-length audio from all of the stuff that I did in this video over on my Patreon, and loads of other things like songs and sample packs. So if you enjoy these videos, think about supporting over there, because it literally funds the electronic components, the times and the machines to get these things made. And also funding this museum is not obsolete, which you can indeed visit and come and see these things in real life if you so please. Anyway, until next time, I'm Look Mum No Computer. I'm going to let the Compton organ play you out and have a lovely time. Toodaloo-doo.